Welcome to Chapter 0. In this chapter, we're going to talk about a few ideas that we will be using throughout the semester. We'll talk about division of integers. We're going to talk a little bit about modular arithmetic. We're going to learn a few basic theorems that we will just be using throughout the semester. And it's also a good way to look at some of the notation that we will be using together and also to review a few proof techniques as we go along. So the very first idea that we are going to talk about is division of integers. So we're starting with two numbers that are integers. A and B are integers. Z denotes our set of integers. We say that A divides B, and we write it as A with that vertical bar B if there exists a number k such that we can write B as A times k. So B is just a multiple of A, and k is the other multiple in there. We can say this in different ways. So this notation A bar B, we say A divides B, or we can also say A is a factor of B, or we can say B is a multiple of A. So hopefully this is familiar. Let's look at a few examples. 2 divides 6, and that is because we can write 6 as 2 times something, and the something we are multiplying by is 3. So 2 and 3 both are factors of 6 in this case. Minus 3 divides 15. Here's another example, because we can write 15 as a multiple of minus 3, and that multiple is minus 5. So integers are positive and negative whole numbers, so we can divide by negative integers as well. Here's a non-example. 3 does not divide 10, and that is because we can't find a number k such that 10 is 3 times k, at least not for k being an integer. So 3 does not divide 10. And just as a little note right here, so A divides B is a statement. It's not an arithmetic operation, so it's not like the division sign or something like that. It's really just the statement, our shorthand notation for saying A divides B. So this is not an arithmetic operation. Okay, let's look at example 1. So example 1 asks us to find a quotient and the remainder if 32 is divided by 5. And you've done this for many, many years. You know the standard division algorithm. Let's write down how we learned to do something like this in elementary school, I believe. So we have 32, we divide it by 5, and we're asking ourselves, how often does 5 go into 32? Well, 30 is the next closest multiple, and that is 6 times. 6 times 5 is 32, and then we have a remainder of 2. So we are very familiar doing something like this. Let's throw our notation at it. So that 6 right here, that is our quotient. And then the 2 right here, that is our remainder. And there are different ways that we can write this. So we can say 32 divided by 5 is 6, with remainder 2. We can say 32 divided by 5, writing it using fraction notation, is 6 plus 2 divided by 5. Or we can say 32 is equal to 5 times 6 plus our remainder of 2. And that is the notation that we will be using a lot in this course and in our examples. So right here in this notation, we are seeing our quotient and we are seeing our remainder right here. And we can always write an integer in this way. So let me just frame this because it's an important example. And the next theorem, the division algorithm, tells us that we can always do this when we have two integers. So when we have a and b are integers and b is greater than 0, then there exists unique integers q and r, a quotient and a remainder, with the property that we can write a as b times q plus r, where our remainder r, that is our remainder right here, is between 0 and b. So this is our remainder. And let's talk about that a little bit more. If we go back to our framed box right here, imagine we took 32 and divided it by any other number. No, sorry. We are taking 32 and we are thinking about dividing by 5 as we did before. So if we are dividing by 5, what can possible remainders be? Well, if we take 32 and divide it by 5, the remainder is 2. We already know that. But what if we took another number and we divided it by 5? What could the possible remainders be? They really could only be 0, that's if the number is divisible by 5, or it could be 1 if the number is 1 bigger than a multiple of 5, or it could be 2 as in our example, or it could be 3 if the number is 3 bigger than a multiple of 5, or it could be 4 if the number is 4 bigger than a multiple of 5. Could it be 5? No, if it was 5, we would just increase the quotient by 1 and the remainder would be 0 again. So that's what we are saying right here. So our remainder can only be between 0 and it has to be less than the number that our divisor is. So we already used the notation quite a bit and the terminology. So Q is our quotient, R is our remainder when we take a number A and divide it by a number B. You may want to pause the video here and work through example 2 just to make sure that you understand how the division algorithm works, and then start up again and I'll show you my solution. Okay, so here we have the number minus 21 and we want to divide by 6 and we want to use the quotient and the remainder in this context of the division algorithm. So we want to take minus 21 and we want to write it as 6 times a number q plus r. And we know that r has to be between 0 and 0 inclusive, 6 exclusive. So how can we do that? How many times does 6 go into minus 21? Well, if we take minus 3 times 6, we get minus 18, but then we would have to subtract some more, so that doesn't work. If we take minus 4, we get 6 times minus 4. That is minus 24. That looks promising. So that's minus 24. We want to get to minus 21. That means we need to add 3 to actually get back to minus 21. So that works. We have q is equal to minus 4. And we have r is equal to 3. And note that r right here, we knew that it has to be between 0 and 5 inclusive. It couldn't be 6. If it was 6, then we could just have another copy of 6 as part of that first term right here. Okay, so this is how the division algorithm works.